Well, hi, good morning. Thanks so much for joining me here in my shop on the shores of the ice-free Lake Couchiching. Yes, the winter ice has finally come off the lake, and today is a dark, gray, rainy day. Good day to be in the shop here. So, the last couple of videos I was distracted by some issues with the tube tester, but I'm back working on this radio now, and we're right at the point where it's time to start changing some components, basically some capacitors underneath here. Great, and I'll try to pick a few that would be interesting to change, and we'll see if there's any performance changes in the radio. I still have this asbestos I gotta knock off here, but first, before I get distracted, let's get distracted. So I've talked about this little box here a few times. I'm just going to talk about it for another minute. This is something I bought from China. Thank you, China. I think there's quite a few of these, this type of box around. This is called a kilowatt. And the idea is you plug it in your outlet and plug the item into this, and then this thing will tell you the voltage you're supplying it. It'll tell you the current it's drawing, the power it's drawing. It's an interesting little gizmo. Kind of a modern thing. I was pretty excited to get this actually because there was nothing like this before. Oh yeah? Check this out. Before this was this. Okay, so I acquired this yesterday. I made a purchase of some radios and some tubes, and in the box was this thing. I'd never seen something like that before. Right away I could recognize what it was though. So you can see you would plug it in, and then the thing you want to power you would plug in here. It's just a two-prong device. There's no third prong on here. Well, what the heck would you do with it then? You know, I'm going to have to stop for a minute and run and get something. Actually, you don't need to stop. I have it right here. So you have this plugged in the wall. I'll pretend this is the wall. You got your item plugged in there. You then grab your handy clamp-on ammeter, which everybody has around the house, and you stick it through. And now you can read the current on your clamp-on ammeter for whatever it is you've plugged in. Not only that, this is a ×1 hole, and this is a ×10. So it must be just 10 times as many wraps here or something. But if that's not enough for you, this guy will let you measure the voltage too. And two little holes here for sticking in your voltmeter lead. So you can get voltage and current, and then with a little bit of arithmetic you can get wattage. Well, you can get something close to wattage anyway. You can get volt amps. So there you are, the new, the old. You know, somehow people built the pyramids without any modern technology. So just because we're in the modern world doing things a certain way doesn't mean they weren't done some other way in the less modern world. We're just going to get this up here. Okay. So, which capacitors to do first? Usually I like to do this in some kind of sensible order. Probably the best way is to start with the audio end of this radio and just change the capacitors in the audio section of it. Just for fun. But first I got to get rid of this asbestos here, so I'm going to soak this with water. I'm going to scrape it off and be done with it because I don't like it there. There, that's most of it. It's just a little more to scrape off here. So concerns with exposure to asbestos are mostly related to asbestos workers, asbestos miners, people installing asbestos-laden products, cutting asbestos-laden products, especially asbestos insulations and stuff like that. So you know, you really need to be in a pretty heavy asbestos particulate environment to have a serious concern, in light of the fact that we all face all kinds of risks every day. This is just another one here. So there we go. Asbestos probably in the big picture saved a lot of lives from preventing a lot of fires. So on balance, probably a winner. Asbestos is a big deal in Canada. Canada has a huge supply of asbestos, I think, from Quebec. And I'm afraid we're one of the countries that has supplied the world with large amounts of asbestos. So I'm just letting you see how I do this in case you're concerned. You have a radio with asbestos in it. You're wondering what you're up to. The whole thing is to not get the particles floating around in the air. That's kind of the objective. And, well, this is a very small amount. I'm no concern doing this in my shop. But any larger sheets, I won't do it in my shop. I'll take it outside, which is what I did with the cabinet of this radio, which had a sheet in it, which it doesn't now. Okay, I think that's pretty good for now. Now, without spending time studying the schematic, I think I can identify which tube is which pretty easy just by looking under here. So, you know, first of all, the antenna's up here. So the antenna circuits, front end of the radio is going to be up here. You can see all the antenna coils, oscillator coil, things like that, all up in here. So this has got to be the front end of the radio. And opposite to that is the speaker down here. So you can also look at where the power cord comes in, or where the wires come out of the transformer. They go right to this tube. So this has to be the rectifier tube. So the front end tube's a rectifier tube. Now down near the speaker you expect to find the output tube. You know, I would kind of guess, it's probably a very good guess, this is the output tube, just from looking underneath here. And then the output tube is driven by a preamp tube, so you can kind of just see how the wires are running here, coming from here. So here's the additional audio input, and it's connected to this tube. So this is pretty sure to be the first audio amplifier. Along with doing that, it's going to have the detectors in it. That's just the way they build these tubes. You'll have a couple of diodes in it, so this is also the detector. You can almost see the chain feeding it, and again, I don't know if this is absolutely correct, but I certainly see something going like this, going to it from here. So this tube is between the two IF cans, so this is almost certainly the IF amplifier, and what are we really left with? The front end tube up here. So if we want to do the audio circuits, it's this and this, these two guys. Some of the components around this tube are related to the detector, but the detector is what is creating the audio, the useful audio signal. So in a sense it would be basically every capacitor below my hand here. They clean up the audio part of this radio. That would include this cracked one here, and I think I saw this one was cracked too. And get them all out. So that's 1, 2, 3, 4, 5, 6, 7 capacitors just in the audio section. So that's what I'm going to work on. I'm going to get rid of those 7 capacitors. Is it worth doing a study? Now, we kind of heard this radio play. It sounded pretty good. This one's got a bit of a warp in the speaker cone, so I'm a little worried about it. But you know what? I think we'd be wise to test this guy properly. And listen to I can feed in an audio signal here. We'll listen to what comes out of the speaker. Let's make some judgments on its current condition before I get in there and change all these parts. That means I gotta power it up. Maybe I should go ahead and put the new power cord on it at this point. Why don't I do that? I don't know. Why don't I? That's a good idea. I'm gonna put a power cord onto this guy. Okay, I just was gonna perform a quick test here off camera, and I got such a weird result on my meter. I decided to show you what's happening. So this is something I've never done before. Just check the resistance between the chassis and the incoming power cord. What I'm expecting to see is an extremely high resistance or virtual open circuit. Instead, my meter is doing this crazy cockeyed thing here. I don't know what to make of that. Oh, it seems happy now. So what was that? Was that a loose connection somewhere? Mysterious things that fascinate me. Well, that's what I expect. Open circuit or extremely high resistance. All I'm doing is measuring the resistance of the primary of this transformer against the chassis. What I'm looking for and hoping to not find is some kind of leak or low resistance condition. The flipping meter there, I don't know what to make of that. I've seen this a couple times now. I'm not even sure if it's always with this meter. Okay, so it seems okay now. It's giving me what I want to see. Anyway, open circuit. Excuse me. Well, it's nothing unusual going on. I don't know. Maybe it's my meter. Okay, that's fine. Just wanted to show you that. This is a test I'm probably going to do for a while until I get used to what the findings are on it. I would expect high resistance every time. The reason I'm doing this is because I got quite a shock off a piece of equipment, and I've just become a little extra concerned about this kind of stuff. Okay, onward. Okay, so the wire is supposed to come in through this little hole. That's how it was done originally, but there should be a grommet in there. So I have all my grommets here to pick from, and we'll see if that's too big. Let's go down one size. Okay, that would be this. This looks pretty small. Oh, it's good there. Any chance I can get the wire through it and into there. That's good. And 1, 2 here. Excellent. And the other one, we got to figure out what to do with this. Either we have to make an airborne connection, which is probably what's going to happen, or we have to find a spare terminal. Sometimes there's some on the rectifier tube. It's very handy. Get over there. Yikes. I have to bend that wire quite a ways. You do not want to crack them up in here. To terminal or not to terminal? That is the question. Okay, so after a little bit of thought, I've decided against using a terminal, a spare tube terminal, and instead I'm going to make a floating connection similar to what was there already. Not the one you're looking at right now, of course. This is part of the power line connection to the switch. Have to solder that right away. Kind of squeezing that around a ball of solder, and the solder is going to melt anyway. A little while to heat all that up. There we go. Come on, on the wire too. It doesn't really look like it's turning into one great big solder blob here. Solder's not penetrating the old wire at all. That didn't go well. Put just a touch of rosin on that, I think. Just a touch here. Yeah, I'm using an old piece of wire. That's right. Okay. Old piece of wire to deliver the rosin. Now, we'll try again with the soldering iron, and this time hopefully you'll see a big difference here. It is soldered, it's just not soldered well. A lot of heat in that built up in there. Now, how well did that come? It's crap. It's crap. Okay. Yeah, be a little more dramatic here. I got that stuck on there. Kind of what you want, but not with all this loose wire here. This is no good. So I'm gonna Try some fresh wire, but often the wire just up in the insulation here isn't any fresher than the stuff that was sticking out. It's completely black. So I think what's been happening here is the rubber contains some kind of volatile component, a gas or something. I don't know what it would be. Messing up these wires here. A little bit of sandpaper. Lots of copper showing now. So I just want that wire to kind of lay there naturally while I solder it. But it's just barely sitting there. I don't think that's going to work. That's probably good enough. There. Okay, now we're going to get a nice job. So what I'm going to do is I'm going to prepare this end a little more. Through the hole like this now. I want all the strands to go through. Come on, guys. think I got it. Okay, well, that'll solder up nice. Yeah, let's try that. I think that's got it. Yeah, for sure. Okay, that's connection number 1. Now, connection number 2. This guy here, a fair bit of flexibility in the wire here, but pretty stiff up in there, I think. We got these two guys looking like that. I'd rather have them looking like that. Yeah, let's try that. Gonna solder. Put a touch of solder paste on that. Sometimes it's tricky to see that the solder is getting on both wires. And the preferred wire will wick up all the solder. Looks pretty good. Just cool it off. Try shoving the shrink sleeve over this until it's cooled off a fair bit. That's definitely connected. Ooh, still a little warm. Okay, let's see if we can slide the sleeve over it. Good. Now we'll shrink it. Doesn't have to shrink, you know, fully or anything, just enough to grip it, and for sure it won't slide. And that's that. Okay. So that's the power cord done. That's pretty good. That's really pretty good. If I say so myself. Okay, good show. Now we got a nice safe power cord on here. Still non-polarized. Okay, now onwards to the different capacitors in there.